Hi, I'm Scott McLean from transmusicmastery.com, and in this video I'm going to go through an explanation of harmonics to help solidify the theoretical foundation that I laid out in the Anatomy of Sound presentation. So let me walk you through the project and kind of give you an idea of what I have set up here. Basically, I have 12 different sine waves. I've got a sine wave starting at 200 hertz. So let me play that. Okay, I have the volume down quite a bit, so let me bring that up some. In fact, I'll set it at -12 because it's going to get louder as I bring in more sine waves. Now, then what I've done is I've created a harmonic, and if you recall from the Anatomy of Sound video, the second harmonic would be 2 times the fundamental frequency. So, given a sine wave of 200 hertz, the second harmonic would be twice that, which would be 400 hertz. So let's listen to that one. Okay, and then I've done that for each harmonic or each integer multiple of the fundamental, which in this case we're starting at 200 hertz. So I've got a 200, 400, 600, 800, 1000, 1200, 1400, 1600, 1800, 2000, 2200, let me change the color on that, make it easier to see, and 2400 hertz. So that gives us 12 harmonics to deal with, or the fundamental plus 11. So another thing I have set up in this project is 2 instances of the signal analyzer from rs-met.com, and I have one set for displaying the spectrum, and then the other set for displaying the oscilloscope. And so now if I solo the fundamental, which in this case would be the 200 hertz sine wave, we can see that we've got the sine wave shown in the oscilloscope display. And then over here we can see that we've got a 200 hertz frequency present, and that is in fact the sine wave that I'm playing. So now what I'm going to do is just go through and solo each channel, and you'll see how each of these appears in the spectrum analyzer and also the oscilloscope. And I'm just going to unfreeze the displays, and then now I'll play each sine wave individually. Okay, so each one of these, as I said before, is just a sine wave, okay? And what I want to do now is take this first sine wave, which is 200 hertz, and I'm going to combine it with a sine wave at 400 hertz, which would be the second harmonic based on a fundamental of 200 hertz. So if we play both of these together, in fact, let me play the one, then I'll bring it in. You can see how the wave shape has changed because what's happening is both waveforms are being combined or added together, and we end up with this resulting shape. Now if I pan one to the left and one to the right, now we can see both waves independently from one another. And what happens is when we sum these together, we just add them together, the shape that we get is what we started with before. And unfortunately, I don't have a separate left, right, and sum display on this particular plugin. But if I just pan these back to the center, you'll see the resulting shape. And now if I add the third harmonic, which is at 600 hertz, and that's 3 times what the fundamental is, which in this exercise we're starting at 200 hertz. And then I can continue and go up the line here. And so we get a more complex wave shape shown in the oscilloscope here. And then we can see that in this case, each of the harmonics is at the same level. All right, that's because they're all at 0 dB, and each of the waves has been generated so that it's at a 0 dB level. So they're all at 0 dB in this case. So if you were going to try to recreate this, you would need to generate these waves, make sure that they're all generated at the same overall level. In this case, I've generated them at 0 dB. Now, I'm going to provide all these sine wave samples and this project, but I'll also provide the individual sine wave samples so that if you're not using Ableton Live, you can actually reproduce what you see me doing here and experiment with it on your own. Now, what this is an example of is it's a complex waveform, okay? And in the next few videos, I'm going to look at how to create the saw, square, and triangle waveforms by adding each of these harmonics together with the correct relative level. So they're not going to be all at the same level like they are in this particular case. If you do that, then you end up with this particular waveform, okay? There's a certain relative level that each of the harmonics needs to be at to generate a saw wave, a square wave, and a triangle wave. And we're going to do that in the next few videos. I'll see you in the next video.